My name is Malcolm Bailey.
My name is Evan Carbine.
And we worked on the Arduino UV sensor project. The basic premise of this project was to create a little board capable of detecting UV radiation and then printing out a number indicating the severity of it. For a little background, ultraviolet is a form of electromagnetic radiation with a wavelength from 10 nanometers to 400 nanometers, which is shorter than visible light, but still longer than X-rays. UV radiation is present in sunlight and constitutes about 10% of the sun's radiation. Intense repeated UV light exposure is known to cause, wrinkling, freckles, sunburns, melanoma in terrible cases, and all kinds of other types of skin cancer. And this affects a huge amount of Americans. So part of our inspiration for this project was to help people be a little bit more aware of this sort of thing and to be able to take measures to avoid getting sunburns in the future if they can help it. Particularly in Utah, a state with high elevation, with the atmosphere being a little bit thinner, we also are even more at risk to extended UV exposure and higher limits. UV in general is on a scale between 0 and 11. During the middle of the day, between usually 12 and 3 is when it particularly reaches a maximum. Otherwise, it's usually just between, values of 3 and 7 sort of thing. Part of this project was interesting because we sort of learned a little bit about UV indexes, and basically coming into it, we figured it's hard to gauge really how strong it is outside without sort of having a quantitative measurement. And it's also easy to lose track of time. So having tools that are, portable and easy to read are a helpful way to sort of, just be aware of that thing and sort of avoid problems in the future, like the ones I mentioned earlier. Not only that, the forecasts that you could consult online are typically for an area, and they don't account for variations that are, smaller than a zip code, whether that be shade or, temporary cloud cover or, any number of factors that could affect it just locally where you are. So that was another inspiration for creating this project. With that in mind, we set out and we bought a couple components in order to assemble a UV detector. Basically what it consists of is it has a LCD monitor here, which prints out values that we detect. We have our Arduino based board here, and then this little red quick sensor here is the way that we actually detect the light, which wires directly into this Arduino, thankfully. And then from there, the information is spit out onto the display. So as a little quick demonstration, unfortunately it's cloudy out today, so we'll see that it's not going to be huge numbers, but it's reading 0.1 right now. And if I
go ahead and
cover it, it'll be 0. And then if I, reveal it again, basically, and show it in the light, then we'll see, theoretically, it should go up back to 0.1. Come on, please do it.
We're losing light, bad.
Well,
let's see.
Too cloudy. That's the problem, and our UV LED doesn't happen to work anymore. But rest assured, earlier it was printing out correct numbers. So that's generally how it functions. And my partner here, Evan, will go into a little bit more detail about the specific parts we have, just in a quick list for the sensors and the other components, and then he'll review the code, potential improvements we can make forwards, and the lessons we've learned along the way. Take it away.
All right. So for our hardware, we have a VEML6075 UV sensor, a Blackboard C Arduino Uno based board, and a 1.44 inch red serial 1280 by 1280 SPI color TFT LCD display module. That's a mouthful. Basically how our code works is when the sunlight hits our UV sensor, that data is transferred to the Arduino as an electrical signal. Now we can read in that electrical signal and convert it to our UV index using the library that they have for the sensor, which is very helpful. Once we've calculated the UV index, we draw a header at the top of our display and as static text, and then we calculate the UV index just underneath it. and that refreshes every 1,000 milliseconds. And basically we redraw it every single time to make sure that it updates correctly. Now, potential improvements, we could do soldering to reduce the size of the product, using a UV transparent monitor that would allow the UV sensor to function behind the monitor, expanding code features to include features that can remind a user to apply sunscreen or show them how much time until serious sun damage occurs, and that would vary based on how intense the UV index reading actually is at that time. Connecting to other devices and Bluetooth capability, and also accounting for cloud cover, light in the calculation of the time to burn. We have a lot of clouds out right now. Conclusions and lessons learned. Our device was an interesting application of hardware and programming. We learned a lot of lessons throughout the duration of the project. Among those lessons were needing to identify how different sensors connect to the main board. The UV sensor had a couple different ways of being attached to the Arduino Uno. Beginning earlier would have helped us so that we could create a more feature-rich version of our application. Understanding the flow of data from a sensor into an Arduino and then out to a LCD display. And we also learned how to use libraries for specific pieces of hardware in order to extract valuable information from our sensors and just from our input in general.
A couple other lessons we learned. One, you cannot predict the weather, and it's probably wise not to save that until the last day. And it's also important to communicate clearly, obviously, between different team members, as there were some different visions on sort of how this device would manifest in the end. And outside of that, it was very interesting to learn how the data flows and understand how you can get electrical signal in from one thing and convert it and sort of calculate and get meaningful information, as well as some of the more intricate things behind it, how an Arduino works and what I2C is as a layout for circuitry. And overall, it was a really interesting project, and it was cool, and it was a little bit challenging.
Right now, while we've got a little bit of light, let's go ahead and just show the display.
Hold the sensor, and I'll show the display.
Okay, we've got it at 0.1.
Legendary.
If we cover it up,
yeah,
it'll go down to 0.0.
Yeah,
that's about as best as we're gonna get for UV light right now. But before the clouds came in, we were getting levels of 0.5, 0.4, and they fluctuated as expected.
Thank you for watching our lecture and bearing through this terrible thing that it was. Look forward to reading your guys' projects. Thank you.
Hello, my name is Evan Carbine, and welcome to the demonstration for the Arduino UV Index project. Previously, we were unable to demonstrate our project effectively due to poor weather conditions. However, the sun is not quite out now, but it's much hotter, and there's less cloud cover, so we'll be able to get an effective UV readout. Here is our sensor. Now, it's currently reading 0, obviously, because we're inside, but my power supply also has a flashlight on it, so if we hold that up to the sensor, we get just a very small UV readout, which is expected because there's not much UV light coming out of this flashlight here. But let's go ahead and take the unit outside and see what kind of readout we get. All right, we are now outside. We can see that our UV sensor is reading 2.7, somewhere around the 2s, which is a very low level of UV. We can see that if we go ahead and cover the sensor a little bit, it will very much dampen the amount of UV light that is hitting the sensor, and then we can cover it completely, and it just reads a flat 0. When we can remove it, and there we go. So the microcontroller is detecting the UV signal from there, and we are converting it using our code and spitting that data out to the display. Once we have the data from our code, we go ahead and draw this static text that says UV index at the top, and then the result that we get from our code, which is the UV index, we have it refreshing every 1,000 milliseconds or every second, and basically we're drawing the UV index to the screen and then getting ready to erase it so that when we draw it next and the program loops, it does not overlap. So we're drawing, we're erasing, and then we're printing the new number on there. Right now it's a static 2.2, 2.3, and it looks like UV levels are just steadying out. But that pretty much does it for our demonstration. Thank you so much for watching, and have a great day.